Good evening, everyone. Welcome to the Retail Insights final presentation. My name is Maxine Xiong. Today, my talk is on enhancing retail online sales through customer retention analysis. This presentation is based on Centauri Alpha's data analysis projects that we recently took for a retail business client. The goal of the project is to propose an effective business strategy that helps our clients increase their total online sales revenue. The strategy that we propose and evaluate in this project is removing high churn risk items from our clients' product offerings, which we estimate could potentially boost total online sales by 10.6% and increase the customer retention by net 6.2%. Before we dive into any details, I'd like to spend a couple of minutes quickly going through the analysis roadmap that led us to our final insights and recommendations. So we took 4 steps in total. At the first step, we loaded data from GCP BigQuery. And what you're seeing right now is the DAG lineage graph of the existing models in our BigQuery data analysis. I can just collapse that. Having reference to the relevant models, we built and deployed 2 extra models, including paid order details and customer churn threshold. These 2 models basically include everything we need, so we imported to our local environment for analysis. Then we went ahead to identify customer behavior factors that significantly influence online sales revenue. Based on the available online sales data, we can identify 2 key factors related to the total customer spending. One is each customer's order frequency. The other one is each customer's average spending per order. To identify how each factor impacts the total customer spending, we first need to determine which correlation method to use. In our case, we evaluated and chose between Pearson's correlation and Spearman's rank correlation. We then identified the correlations between total customer spending and the 2 key factors using the determined correlation methods. Those relationships were then tested on their statistical significance to determine how much level of confidence we should put into those correlations. Coming next, we assessed the customer churn risk for each product. We first determined whether each order is followed by a repeat purchase. This is very necessary to computing customer retention probability for each unique product using Bayes' theorem. We then classified the customer churn risk for each product using their binomial confidence intervals, which are calculated based on their corresponding retention probabilities. As a result of this step, we managed to identify which products have a high risk of leading to customer churn. To evaluate whether removing those items could result in positive impacts on clients' business, we first determined the general estimated retention probability and the original retention probability for orders that include high churn risk items. These metrics are key to computing how many extra repeat purchases could derive from removing those items. We then can estimate the potential revenue increase associated with those repeat purchases. Finally, we also evaluated the trade-offs between customer retention gains and losses. Coming next, we'll go through those steps in more details. At the first step, we imported 2 models that include everything we need. We have paid order details that contains the scoped dimensions and measures such as the order ID, customer ID, item, order price, item price, and it focuses exclusively on orders that were successfully paid. We also have customer churn threshold that maps churn threshold to each unique customer. The customer churn threshold, specifically speaking, is set at 1 standard deviation above each customer's average purchase intervals, which helps us identify if a purchase made by a particular customer is a new purchase or repeat purchase. At second step, we identified which customer behavior have a substantial impact on total customer spending. Is it order frequency or average order value or both? The order frequency counts the number of orders that a customer places over a specific period, and average order value reflects a customer's average spending per order. At this step, we examined the correlations between total customer spending and the 2 key factors which informed our strategies to either encourage more frequent purchases or increase the average order value or both, ultimately guiding us towards actions that effectively enhance total online sales. To examine the correlations, we need to first determine an appropriate correlation method to use. The most two common types of correlation methods that we can choose from include Pearson's correlation method and the Spearman's rank correlation method. The Pearson's correlation method, So the Pearson's correlation methods works best for variables that are normally distributed and measures how closely the data fits on a linear line. The other method, Spearman's correlation, on the other hand, does not require the variables to be normally distributed and reflects how well a monotonic function can represent the relationship between variables. The monotonic relationship, to be brief, is consistent association between two variables where the independent variable is either consistently increasing or decreasing as the dependent variable goes up, but not necessarily at a constant rate. Additionally, the Spearman's rank correlation allows for the existence of outliers. In our case, we investigated the distribution of total customer spending. The distribution, as you can see here, is actually right-skewed, not normally distributed, and contain outliers apparently. Therefore, we chose Spearman's rank correlation method for identifying the relationships between total customer spending and the two key factors. Using the Spearman's rank correlation, we computed, down here, we computed the correlation coefficient for both relationships. In our analysis, we got a correlation between 0.8 and 1, which indicates a strong positive monotonic relationship between total customer spending and order frequency, and a correlation between 0.4 and 0.8, suggesting a moderate positive monotonic relationship between total customer spending and average order value. But can we trust the observed relationships? To determine the level of confidence we can place in the observed correlations, we performed hypothesis tests of both relationships and found that both p-values are below the significance level of 0.05. Therefore, we rejected both null hypotheses and concluded that both relationships are statistically significant. So now we can be confident in both relationships. As customers place orders more frequently, their total spending tend to increase accordingly. On the other hand, higher average spending per order is somewhat associated with increased total spending, but this relationship is just not as strong as with the order frequency. The analysis we conducted at this step reveals that repeat customers contribute more significantly to total sales than customers who make high-value purchases per order. Therefore, implementing business strategies aimed at encouraging repeat purchases and enhancing customer retention is likely to be more effective in boosting total online sales. We all know that products play a key role in influencing customer retention. By evaluating the churn risk associated with each product, we can identify the specific items with different levels of potential to lead to customer churn. These insights enable us to develop targeted strategies aimed at optimizing clients' product offerings to better align with customers' preferences and expectations, thereby enhancing customer retention. To evaluate the churn risk of each item, firstly, we need to determine if each order was followed by a repeat purchase. For each customer's order, if the number of days between current order and next order does not exceed the churn threshold, then the next order is considered a repeat purchase. Otherwise, it is a new purchase. The step is necessary for computing the customer retention probability for each item using Bayes' theorem. The customer retention probability in our case is the estimated probability that a customer will make subsequent repeat purchase after buying the specific item. The Bayes' theorem expression after a series of transformations becomes eventually like this. In plain language, the customer retention probability for a particular item is the ratio of the number of orders for that item that are followed by a repeat purchase plus a smoothing factor to the total number of purchases of that item plus twice the smoothing factor. If you are curious about how the Bayes theorem formula is transformed to be this expression, you can feel free to check out my technical blog post that provides detailed steps and explanations. When classifying product churn risk, we face another challenge: small sample sizes. For some items, the number of purchases is so small that their individual probability estimates may be unreliable. This happens because, as stated by the law of large numbers, as the sample size increases, the sample mean will converge toward the true population mean. In contrast, smaller samples are more likely to deviate from the true probability, leading to the biased estimates of an item's true retention probability. A good way to address this issue is by calculating the confidence interval for binomial proportion for each product. The confidence intervals provides a range in which the true probability is likely to lie. For smaller sample sizes, the confidence interval widens, reflecting greater uncertainty in our estimates. In our analysis, we used the Wilson score interval for each item, since it's the best for small sample sizes, to determine the lower and the upper bounds, which help us classify the churn risk of each product. The Wilson score interval expression are shown here, but don't be overwhelmed. The stats models API handles all the complex calculation for us. The key step is comparing the lower and the upper bounds of each item's confidence interval against the threshold that we set. In our case, we set the median of estimated retention probabilities across all items as the threshold, and this comparison allows us to classify each item's churn risk as high, low, or moderate. Specifically speaking, if the upper bound, which is the right end of the black bar, if the upper bound of an item's confidence interval is below the median threshold, it is recognized as a high churn risk item. But if the lower bound, which is the left end of the black bar, if the lower bound of the confidence interval is above the median threshold, is categorized as low churn risk item. And also, if the median threshold falls between the lower bound and upper bound, the item is classified with modern churn risk. As a result of this step, we identified 11% of products as high churn risk items, 24% as low churn risk items, and 65% as moderate churn risk items. Now that we know what are the high churn risk items, what we wanted to know what would happen if the high churn risk items had been removed. To evaluate the strategy, we first assumed that if these products were removed, customers would purchase alternative items with moderate or low churn risk in place of the removed high churn risk items. This is our assumption. We first determined the general estimated retention probability across the orders that originally included high churn risk items after those items are removed, which is the median of the retention probabilities across the moderate and low churn risk items. This is because according to the distribution of these retention probabilities, they are just tightly clustered around the median. So using the Bayes theorem formula that we discussed earlier, we can also calculate the original general retention probability for the same orders as well. Using these two metrics, we further calculated cumulative counts of repeat purchases before and after implementing the strategy. To demonstrate the calculation, let's have a look at this simple example. Let's say we have 100 orders that originally include high churn risk items. The original general retention probability before implementing the strategy is 50%. So applying a retention probability of 50% to these 100 orders would result in 50 orders, leading to subsequent repeat purchase. And these 50 repeat purchases would in turn generate 25 additional repeat purchases, which would further produce approximately 12 repeat purchases and so forth. If the estimated retention probability after implementing the strategy is brought up to 80%, then the 100 orders would generate 80 orders, and all 80 orders would generate 64, and 64 would produce 51, and 51 produce 40, and so on and so forth. The goal of this step is to compare the figures before and after implementing the strategy. To calculate how many additional repeat purchases in total would be generated from removing those high churn risk items. So below is the analysis results we got. Before strategy implementation, the cumulative count of repeat purchases accounts for 3.7% of overall purchase count. But after implementing strategy, it accounts for 8.7% of overall purchase count. Therefore, we estimate that removing high churn risk items could potentially generate additional repeat purchases that accounts for 5% of the overall purchase count. The potential revenue associated with these additional repeat purchases can be estimated using the average spending per order across customers who place the orders, including high churn risk items as shown in the expression here. The potential additional revenue estimated in our analysis represented 10.6% increase in total online sales. Although removing high churn risk items could potentially retain customers who originally churned due to the purchase of those items, it may also result in losing the loyal customers who regularly purchase those items. By evaluating the trade-offs between customer retention gains and losses, we estimated that removing those items could lead to a potential retention gain of 6.7% of the total customer base. On the other hand, the customers who might potentially churn due to the removal of their favorite high churn risk items only accounted for 0.5% of the total customer base. Therefore, the net impact on customer retention is positive. The number of customers retained would far exceed those potentially lost, leading to a net retention gain of 6.2% of total customer base. In conclusion, the strategy of removing high churn risk items from the client's product offering is estimated to be effective. It will help boost the total online sales by 10.6% and increase the customer retention by 6.2%. Thank you all for joining me on this journey through the presentation. Your patience is kindly appreciated. I'm happy to address any questions you may have now.